This diagram illustrates the core architecture of a modern AI agent. Unlike standard chatbots, agents operate in a continuous loop. They perceive their environment, reason about their objectives, and take actions to achieve a specific goal. To take those actions, today's agents are equipped with an array of tools. These give them the mechanical ability to search the web, execute Python code, and pull records from enterprise databases. But giving an AI the mechanical ability to trigger an API doesn't mean it understands the procedural logic required to use it safely. A tool only provides the execution path. It doesn't teach the agent your company's specific workflows or compliance rules. To bridge that gap, developers have relied on a brute force workaround. They stuff massive, complex instructions into the agent's main system prompt, hoping the model remembers every edge case and standard operating procedure for every possible task. Overloading the system prompt pushes these models past their limits. Context windows overflow, token costs skyrocket, and the agent suffers unpredictable black box failures. For AI to survive in high-stakes production environments, we have to move past this fragile architecture. The industry must transition these systems from unpredictable generalists into reliable, specialized experts. This transition requires a strict division between the AI's external hands and its internal brain. In this matrix, tools are external, deterministic interfaces, like APIs, dictating what an agent can mechanically do. Skills are internal, probabilistic workflows, dictating how the agent executes tasks, applying logic to its tools. Agent skills package human-authored expertise into a highly portable, standardized format. Structurally, a skill is just a standard OS-style file directory. At its center sits a primary SKILL.md file containing specific instructions, surrounded by any optional reference documents and executable scripts the agent might need. By isolating procedural knowledge into these discrete, interchangeable folders, developers no longer have to cram every rule into a single system prompt. The mechanism that makes this architecture work is called progressive disclosure. It is the engine that prevents an agent from crashing its memory when equipped with hundreds of different skills. In Phase 1, discovery, the agent reads only lightweight metadata. In Phase 2, activation, it expands the relevant skill's full instructions into active memory. In Phase 3, execution, it follows those steps, routing connections to external tools. To see this in action, consider a classic enterprise scenario, tasking an agent to audit a Q4 financial report. An unskilled agent with raw access to financial APIs will often parse files randomly, producing unstructured data dumps or even hallucinating numbers. But an agent equipped with a financial audit skill behaves entirely differently. The skilled agent follows a strict logical sequence. It imports the 10K data, checks for accounting anomalies, structures results into comparative tables, and verifies the math before it ever generates a final output. This method allows an agent to maintain a massive library of specialized capabilities that stay dormant until needed, preserving processing speed while ensuring task accuracy. Deploying skills in a production environment delivers immediate economic returns. By replacing sprawling system prompts with targeted, on-demand instructions, organizations enforce strict workflow governance while massively reducing token consumption. This chart demonstrates the token efficiency of specialized instructions. For example, a popular developer skill called Caveman strips out conversational filler and reduces an agent's output tokens by up to 65% while leaving the necessary code blocks completely intact. Today, agent skills function as an industry-wide open standard, with native support across dozens of major AI coding tools. This creates a write once, run anywhere reality. The exact same SKIL.md file you build for one platform can be seamlessly plugged into entirely different environments, transferring your specific domain expertise across the entire ecosystem. The utility of enterprise AI depends on the richness, precision, and portability of the specialized skills we build to guide the underlying model.